Okay, so let's get some practice with scientific notation. So question number one has us converting from decimal notation into scientific notation. So here we have 2003 meters. The question is, what is that in scientific notation? So the number between 1 and 10 would be 2.003. And we would move the decimal point 1 to 3 times in the positive direction. So we would have 2.003 times 10 to the third meters. And make sure that we keep that unit. All right, let's try another. 134.5 seconds. So the number that we would have between 1 and 10 would be 1.345, and we would have to move the decimal point 2 places in the positive direction. So we would have our decimal part 1.345 times 10 to the 2 seconds. So 545,000 milliliters. So we don't have a decimal point, so we'll put one here, but we'll keep track of that when we think about what to do with these zeros, because we don't know if they're significant without a decimal point. But from this location to move to a number between 1 and 10, that would be 5.45. So we'll have to move our decimal point 1, 2, 3, 4, 5 locations to make a value of 5.45. And if we're not sure about these zeros, we're going to let them drop, assume they're not significant, and say times 10 to the 5th milliliters. Forgot how many I counted. Okay, so we have a number less than 1 miles, a short distance here. So our number between 1 and 10 would be 1.58. And so to get there from our starting location, we're going to need to move the decimal point 1, 2, 3, 4, 5 times in the negative, in the less than 1 direction. So our final answer will be 1.58 times 10 to the negative 5th miles. Mm-hmm. 11,451,000 people. So our number between 1 and 10 would be 1.1451. We'll put our decimal point in here. We'll probably drop these zeros because we're not sure if they're significant, if they've been counted all, but our number will be 1.1451 times 10 to the 1, 2, 3, 4, 5, 6, 7 people. So less than 1 meter, to get a value between 1 and 10, I would have 4.56 times 10, and I'm going to move the decimal place 1, 2, 3, 4, 5, 6 times in the negative direction, meters. Whoa, All right. So a very large number, put our decimal point in here. Let's go all the way and find a number between 1 and 10. It's going to be 6.022 times 10 to the 1, 2, 3, 4, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Oh, off to a bumpy start there, but I pulled it off in the end. Atoms, of course, Avogadro's number, 6.022 times 10 to the 23rd atoms. That's not relevant yet. It will be. All right, a number that's much smaller than 1 second. So let's find a number that's between 1 and 10 for the decimal part. And that would be 1.21. How many places we would have to move the decimal point from its original location to get to 1.21 would be in the negative direction and less than 1 direction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 times. So we have 1.21 times 10 to the negative 13 seconds. All right, so for the second half of this assignment, we're going to be taking numbers already in scientific notation and adding zeros either before or after, whether the number is going to turn greater or less than its starting value. We're going to be adding zeros and trying to see what the number is in decimal form. So 13.7 times 10 to the 9 years. So this one comes from a textbook. It's written as the age of the universe. This should be 1.37 times 10 to the 10 years, but let's excuse the textbook's incorrect scientific notation writing. We'll move from this location 9 times. So we're going to have 13.7, and we're going to need some zeros. And from here, we're going to move 9 times. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 times years. And to write that a little prettier, we can have 13,000, 13,700,000,000, third time's a charm, years. All right, let's try another one. 1.1 times 10 to the negative 4. So this is going to be less than 1. So we're going to add zeros, but in the less than 1 direction. So start with our 1.1. To the left, we'll add a few zeros. I'm sure we have enough this time. And now we'll move it negative 4 places. So 1, 2, 3, 4. So we'll have 0.00011 meters. (9.43 times 10 to the negative 6 grams. And so this is less than 1 again. So we'll be adding in zeros before our value. And move negative 6 times 1, 2, 3, 4, 5, 6. Put a leading zero there. Our final answer would be 0.5 zeros 943. Oops. Don't forget the unit, grams. All right, 2.99 times 10 to the 8 meters per second. So this is going to be a number much larger than 1. So the zeros will go after our 2.99, not before. So this is the speed of light. Let's see it in decimal form, 0.99. And let's add some zeros. We know we'll need them. And let's start moving. 1, 2, 3, 4, 5, 6, 7, 8. They didn't need that last one. So 299. So 299 million units, meters per second. So a number smaller than 1 meter is 4.50 times 10 to the negative 7 meters. So start with our decimal notation. We're going to need a few zeros this time. Sure we add enough. Negative 7 times, so we're going to move 1, 2, 3, 4, 5, 6, 7 in the negative direction. Our number is 0. How many zeros? 1, 2, 3, 4, 5, 6. Of course, and then 4, 5, and keep that 0. It is significant. More on that later. Meters. All those zeros is 4.50 times 10 to the negative 7 meters. All right, just a couple more. So a little bit smaller than 1 gram, 9.549 times 10 to the negative 1. So we're going to need, we'll put a couple zeros before 9549. And we'll move in the negative direction 1 time. So just right there. So we'll have 0.9549 grams. Said almost 1. Okay, 1.9 times 10 to the 2 mils. So we're going to be moving in the positive direction 2 times. So we'll go 1, 2. That's 190 mils of whatever. All right, one last one, 7.2 times 10 to the negative 4 seconds. So start with that decimal portion, and we're going to be moving in the negative direction. So we'll put zeros to the left of the value. Make sure we have enough, and we'll move 1, 2, 3, 4. So our final answer would be 0.00072 seconds. So hopefully this helps everybody understand how to do scientific notation, and you can continue on with your chemistry journey. Thank you.